Alright guys, so today's Firestarter is basically introducing circles. We have some ideas about circles. Some of it's going to be review. A lot of it will be review. But there's going to be some new ideas along the way. If we were in, this would have been a flip book. So, but this is kind of the way it is. We're not going to make a flip book out of it. So we're just going to kind of go section by section. Now, what we're going to start with is just the parts of a circle. So we look at this circle over here. And it's really important that we understand that all these different things are different parts of the circle. All right. So the center obviously is just the center point of the circle. So the center is going to be H, right? So center is, that's the center circle. Pretty easy to explain. All right. So now we're going to talk about a chord. So a chord is any segment where the two endpoints lie on the circle. So like a good example that I'm going to use, and the one they want you to kind of think about, is AB. So remember when we draw a segment, it's two capital letters. Because we're talking about a segment, I put the bar on top. Now, in theory, I actually could write BC as long as I put the segment on top. All right, as long as I'm not talking about the line BC. Remember, there's a difference between a line. I could even, if I really wanted to, which we're going to use this later, but I could even say EB. All right, even though we're going to use EB later. So a lot of times you'll see chords like AB, but remember, there's as long as the 2 points are on the circle, right, which means they're on this outside. And I don't like to use the word edge, but if you think about the circle is just the outside edge. All right. So that's a chord. Diameter. It's basically a chord that must go through the center. So 2 endpoints on the circle, and it goes through the center. So a diameter is 2 endpoints on the circle, must go through the center. So that is the only one is EB. All right. So because H is the center. All right. Now we have a radius. A radius is going to start at the center. It's another segment. So it starts at the center. It has to go to the edge. So HG is a radius. Now you also could say H to E is also one. So you don't have to have multiple. I didn't say to give me all the examples, but HE is a fair example. Also HB is a fair example. All right. Make sure you have the segment bar on top. We're not talking about lines here. Okay. All right. So E is central angle. So just so in case you didn't know, a central angle is the vertex of the angle must be the center. The 2 segments must be, it's called radii is how you say it, just multiple radiuses. All right. So a good example here would be EHG. So that makes an angle. All right. And H is the center. So remember you're going to put angle EHG. That is not the only option. I could say angle. I could go from B to H to C. All right. B to H to C. So I could say angle BHC. All right. Actually, remember, you could even argue that EHB itself is an angle because it measures 180 degrees. So you even have another one, which is probably would be the last one you would pick. EHB would be this angle. All right. You couldn't say anything like ABH would not be a good one because B, the vertex is B, and that's on the outside of that lies on the circle. It's not the center of the circle. Okay. Now we're on to inscribed angle. So inscribed angle is an angle where the vertex is on the circle. So B, A, E, G, or C are all points on the circle. The two legs of the angle, or the two sides of the angle, are inside the circle, or are chords. Alright? So, a good example would be ABE. Alright, ABE. So angle ABE would be a good example. I could even say angle ABC. Now, I could not use E because, like DEH, see how D is not inside the circle, so that would not be inscribed. FEH, nope, that's not inscribed. GHE or EHG, that's a central angle because the vertex is H. So anything with B as the vertex is good, because this BC, I could even see, I just saw another one I didn't add in the first place. I could say EBC, right? Or HBC, however you want to write that. But it should be EBC, not HBC. Even though it's kind of the same angle. So, but it had to be EBC, not HBC. All right. Good. All right. All right. So major arc and minor arc. Arc is the, let's say, the measurement of the circle. So, for example, this would be an arc. See how it's kind of rounded, right? It's not a line, right? It's on the circle. So the major arc is kind of like think of it as the scenic route. And that's a terrible way to write scenic, because it's going to be the long way. So think of it as the long way, or like the scenic route. And think of the minor as the short way. Now, usually, if possible, you use a major arc, you're going to use 3 letters. So you're gonna 3 letters. That's going to tell you, all right. Short with the minor arc, usually, if possible, you're going to use 2. All right. So for example, I'm going to pick A to B. All right, A to B. All right, A to B is the shortest way to get from A to B on the circle. So that would be a minor arc. So we're going to say A, B, and you put this little thing over, it's just an arc symbol. Okay. Now, if I took the long way to go from A to B, I would get to pick any of these points I pass along the way. I could say A, EB, A, GB, A, CB. All right. So we'll say A, C, B, and that's my arc. You could also say AGC. You could also say or AGB. So any of that. All right. Semicircle. That's just gonna be an arc that makes up half the circles. That's pretty easy. EAB or EGC. Now remember, when you write it, we're gonna be using that. So we're gonna say EAB. That's a good option. Make sure you put the arc over it. Or you could say ECB. That's another option. Make sure you put the arc over it. Right. Tangent is a line. So tangent is a line, or in theory it could be a segment as well, that touches the circle at exactly one point. So like this line right here, that line touches at E. There's a bunch of properties with tangents, and you use a lot in trigonometry and stuff like that. So I'm going to say DF. Make sure it's going to be a line. So I put the line symbol on top. The point of tangency is just the point that it touches. So that's E. And a secant is a line. So that's really the difference between a chord and a secant. A secant is a line usually, and a chord is a segment that goes through 2 points. So it's very similar to a chord. So a secant, we're going to say BC as a line. All right. I know it's a long-winded explanation, but it was a bunch of little details that we haven't really, you might not be aware of. Alright, so bunch of review here, a bunch of easy stuff. We know that the area formula for a circle is pi r squared. We have done that before. We know that the circumference formula is equal to 2 pi r. That's what I use a lot of times just because I like dealing with radii. But you could also say circumference is equal to pi times the diameter, because remember, 2 radius is equal to 1 diameter. Alright? So, pretty easy to do. We've done this before. Now remember, you can leave your answer in terms of pi if you want, but a lot of you guys will just plug it in your calculator, which is totally fine. So 7, that's a radius. So my area is equal to pi r squared. So I'm going to put 7 in for r, so my area is equal to pi times 7 squared. So you could give me 49 pi, but more than likely you guys are going to put 49. I do not like using the 3.14. I like to use the pi symbol. So I end up with my area, and I use the approximate symbol now, 153.94. Remember, it's area, so it's square centimeters. Don't forget your label. All right? And I'm going to go to 2 decimal places, pretty much all this. So area, you could use, remember, this is a diameter. So my radius is going to be equal to 16 inches, right? Because remember, the diameter is half of that, or the radius is half the diameter. So my area is going to be equal to pi times 16 squared. 16 squared is 256. So you could just write 256 pi. Sometimes they'll say they want the exact answer, and they'll tell you you have to write it in just 256 pi. But more than likely, you're just going to put 256 times pi in your calculator. You might have just done the whole thing in your calculator, which is fine as well. I'm going to end up with 804.25. So 804.25. Now remember, it is square inches because we're talking about area. So pretty easy. Much easier than that last page we just did. More easy stuff. Find the circumference. So circumference, it depends on what you want to do, because remember, that's a diameter. So you could say circumference is equal to pi times the diameter. Right? Or you could use circumference is equal to 2 pi r and tell me the r is 5.5. So circumference is equal to 11 pi. So 11 times pi is 34.56. So my circumference is equal to 34.56. This is circumference, so it is not going to be, it's just normal meters, not square meters or anything like that. Radius, so circumference is equal to 2 pi r. So that is a radius, so it's 15. So circumference is equal to 2 times pi times 15, which is 30 pi. Alright, so I'm going to just put in my calculator. 30 pi is equal to, my circumference is equal to 94.25. 94.25 feet. Now this one's working a little backwards a little bit. So look, I say circumference is equal to 81.68. So my circumference equals 81.68. So they want to find the radius. So I'm going to kind of work a little bit backwards. So I'm going to say, I know that circumference is equal to 2 pi r. Alright. Now I'm going to put 81.68 in there. And now it's just an algebra problem. That's our variable. Remember, pi is just a number, so all I'm going to do to actually make the pi go away is divide by 2 pi. So in my calculator, to find r, all I have to do is 81.68 divided by 2 pi. So 81.68 divided by 2 pi. Make sure you put 2 pi in parentheses. I forgot the first time and it gave me some weird number. So like when you type in your calculator, make sure you put that in parentheses, or you could get the wrong answer. So when I do that, I end up with r equals 13, and we know it's centimeters because it says centimeters there. All right. Find the diameter of a circle with an area. So we know area is equal to pi r squared. Right? So I'm going to put 254 in there. So I have 254.47 equals pi r squared. Remember, that is my variable. So to use PEMDAS backwards to solve, I have to divide by pi first. So I'm going to do 254.47 divided by pi. And with it's about 81. So I get r squared, I just moved it to the left, is about 81. Now, how do I get rid of this little 2? If you guys don't remember, you square root both sides. So r is going to be equal to 9. Now, that's not what they want, though. They want the diameter. So I take that and I multiply it by 2. So my diameter is equal to 18, and it is millimeters. And that's it. Alright, so there's my radius, there's my diameter, circumference, circumference. Got my labels, didn't mess them up, looks good to go. Alright, a center angle is an angle with a vertex on the center of the circle. We talked about that. The sum of all center angles in a circle is 360 degrees. That's a degree symbol, it's not another 0. Trying to make it better. They also tell you here the measure, so this is kind of like notes. The measure of an arc is equal to the central angle that creates the arc. For example, if you have an arc, it's the same as the angle. The length, that's like the measurement, is based off of the circumference. So this is our circumference formula right here. Basically, guys, what it's doing is saying, find the circumference like you normally would, and then divide it by the proportion that you're actually talking about. Kind of how I'll explain that is, imagine I was finding this measurement, right? If that's 2/3 of the, if that's a third of the circle, right? I could find this whole length by finding the circumference, and then multiply by a third to find the third of it. So that's kind of what they're doing. All we're doing here is finding each arc measure, right? So basically, what you have to know is, based off of this idea right here, I can take this 79 and I could say that is 79 degrees right there. Now that only is true if it's a central angle. Alright, if that dot's not in the center, then you can't do that. Alright, I know that this is 43 degrees, which means inside there's 43 degrees, and then because of vertical angles, I get to say this is 43 degrees. So that's because of vertical angles. So right here is 43 degrees. Alright. Now, one thing I do know, let's get a different color, is from here to here, that green mark, so we'll say the measure of arc GHG, that's a semicircle, so it's automatically 180 degrees. So if a full circle is 360, we know half of it. So if I know that's 43, to find the measurement of DH, I'm going to just do 180 minus 43, and I'm going to get 137 degrees. So I haven't even looked at the stuff to the right. I'm just filling out everything I can in the circle. All right. So the whole thing is not 137. So like from here to the blue line is 137 degrees. All right. And then lastly, to find this guy right here, I could just take all these together. So this, and this, and minus 360. So to find the measurement of EF, I'm just going to put 360 minus 137 minus 43 minus 43. I'm just making sure I took care of everything. Minus 79. And I get 58 degrees. Alright, so now I'm just going to kind of fill out whatever they're asking, and so look, EF, first thing we have to do, 58 degrees. DH, we already did that, 137 degrees. G to E. G to E. So I'm going to kind of erase a lot of these marks. So now we're finding G to E. So G to E is 79 plus 58. I end up with 137. And now if you look, the angle GH, or whatever the center, the center. If you look at that angle, if we say the center is A or something, they're vertical angles. So you could have used that idea to do that one. So then our next one is we have H to F. H to F, 43 and 79 is 122, so I get 122 degrees. And then EDG, so see how that's got 3 letters? That tells me it's going to be a major arc, so more than likely this is going to be a big number. So EDG, so I'm just going to kind of clean up all this mess. Alright, just so we can see a little bit better. So we're going to go E to D to G. So DHG is 180, so it's 180 plus 43, so it's going to be 223. And see, I didn't forget the angles, right? You also could have done, if you wanted to, you could have done 360 minus E to G. You could have done E to G first, and then H D F. So now we're going to go H to D to F. So like I said, basically it's 3 points tells me it's going to be a bigger number. So we're going to go H to D to F. So once again, I know H to E right here is 180 plus E to F, which is 58. So 180 plus 58 is 238. And that's it. And that's going to finish this. So a little bit different. Hopefully I explained it well. If you have any questions, let me know.